All right, so guys, we're going to be talking about dividing polynomials today. So quick refresher, when you divide a monomial by a monomial, we are going to be following our power to power rule, or our dividing, our quotient of power rules here. So if we have something like 7x to the 5th over x squared, how would we simplify this guy, y'all? What do we do to those exponents? Do you guys remember? We subtract them, right? And the larger exponent is in the top. So x to the 5th times x squared, or minus, or divided by x squared would be x to the 3rd. And our 7 is still in that numerator there, right? So 7x to the 5th over x squared reduces down to 7x thirds, all right? Now we're going to do another little good refresher here. Let's say I have 6x squared, and then I'm going to say y. I'm going to say 6x squared y squared, and I'm going to do that over 2x y to the 6th power. All right, guys? So if we are going to simplify this lovely little guy here, we have to treat each thing on its own. So guys, what is 6? How can we simplify 6 over 2? What's 6 divided by 2, y'all? 3. So our 3 is up here on the top. And then x squared over x. Well, that's kind of just like x to the 1. So 2 minus 1. So x squared over x, it's just x, and it's still in the numerator because our bigger exponent is in the numerator. And then last, but certainly not least, y squared over y 6th. We are going to have y to the 4th, where the y is in the denominator. Do y'all feel good about that? When we are simplifying, I guess I didn't box my answers here. When we are simplifying our quotients here, right? Or where we're dividing. All right, I'm going to do one more where we have, let's say, 4x divided by, I don't know, 8x cubed. And so how is that going to reduce for us? Does anybody want to tell me what that will give us? 4x over 8x cubed. All right, Jenny, you want to help me out? What's that going to be? 1 over 2x squared. Excellent job, Jenny. That's awesome. So here we go. 4 divided by 8 would give us that 1 over 2. X over x cubed gives us that x squared, and our x winds up on the bottom. Okay? So this is just a quick refresher on how we divide just a monomial over a monomial. So guys, with polynomials, our rule here is when dividing a polynomial by a monomial, man, it's cool. I'll get there. I'm just missing letters. Monomial, there we go. You separate the fraction and simplify each term. What is going on? I am not able to spell today. Simplify each term. Are you guys good with that? So when you are dividing a polynomial by a monomial, you separate the fraction and you simplify each term. All right, guys, so we're going to practice that here today. Okay? So I'm going to look over here, and we are going to say, for our simplify, our example that I'm going to give you guys is I'm going to write 6x squared plus 9x minus 6, and I want to divide it all by 3x. Are y'all cool with that? So we are dividing a polynomial by a monomial. So when we divide this polynomial by the monomial, what we want to do is we're going to separate the fraction and simplify each term. So when I say separate the fraction, how that's going to look is we are going to take this 6x squared and we are going to rewrite it as 6x squared divided by 3x. We're going to separate it out. And then I'm going to do the same thing with my middle term. 9x divided by 3x. So I'm going to say plus 9x divided by 3x. And lastly, with my last term, negative 6 divided by 3x again. Do y'all feel good about that? So we're taking each term in the numerator and we're dividing it by the monomial in the denominator. Okay, so we're going to separate our fraction and then we go ahead and we simplify each term. So now we are going to simplify these guys just like we simplified our examples at the beginning. So we look at this and we say, cool, 6x squared over 3x. Well, that's going to reduce down just to 2x. And then 9x over 3x. Well, guys, this is beautiful. What's going to happen to those x's? They're just going to cancel. And 9 divided by 3 is just 3. Okay? And then with our last term here, negative 6 divided by 3, well, that's going to be negative 2. But we're still going to have our x in the denominator here. So it's going to be minus 2 over x. So our final answer will be 2x plus 3 minus 2 over x. Y'all feel good about that? Okay, let's do another example here. So our second example I'm going to write out is 4x to the 5th minus 28x cubed plus 3x all over, let's do 7x squared. Y'all good with that? Okay, so we have 4x to the 5th minus 28x cubed plus 3x over 7x squared. So we are once again going to take our first term and we're going to separate out all our terms. So we have 4x to the 5th over 7x squared. Cool. And then our middle terms, negative 28x cubed. Make sure you keep your negatives and your positives with you. Over 7x squared. And last but certainly not least, we're going to have positive 3x over 7x squared. So positive 3x over 7x squared. Y'all good with that? Now we just have to go through and simplify each term, right? So now we're going to simplify each term. So this is going to simplify into, let's see here, we're going to have 4x to the 3rd in our numerator over 7. Because x to the 5th over x squared just reduces to x third. 4/7 can't reduce. Negative 28x cubed over 7x squared is going to be negative 4. And then x cubed over x squared is just negative 4x. There's nothing in the denominator of that one. And then over here, 3x over 7x squared. Well, it's going to be 3/7. That doesn't reduce. X over x squared. My x is going to be in the denominator. So this is going to be plus 3 over 7x. How do you guys feel about that right there? We feeling okay? Any questions so far on these first two? No? Do I need to zoom in a little bit so you guys can see better on that guy for number 2 here? Okay? Is that better where you guys can kind of see it a little bit better? Especially in the back. So we got 4x to the 5th over 7x squared gave us 4x third over 7. And then negative 28x cubed over 7x squared gave us negative 4x. 3x over 7x squared gave us 3 over 7x. So you just kind of reduce each one on its own. Okay? And then I'm going to go here. Okay, I'm going to give you guys 2 more examples. All right? And I want you guys to attempt to do these 2 on your own. And then we are going to go over them together. So this is 16x to the 4th plus 8x cubed plus 8x squared all over 8x squared. So that's going to be number 3. And number 4 here is 3x to the 5th minus 4x cubed plus 2 all over x cubed. So I want you guys to take a second and do these guys. 3 and 4. I think I can zoom in. Yeah. Or you guys can copy those guys down and you guys can see what we get there. All right, so I'm going to walk around. I'm going to check it out, see how we're doing. Here. So let's take a look. So guys, I rewrote this guy as 16x to the 4th over 8x squared plus 8x cubed over 8x squared plus 8x squared over 8x squared. So how are we going to reduce this guy here? What is my first, Will, what's going to be my first term here? Michael, can we take all that stuff out of his hood, please? Thank you. Awesome. There we go. Okay, Will, what do we got here for our first term? William, what do we got for our first term here?
2x squared.
Yes, sir. So we got 2x squared. Excellent job. And then for our second term, what did you get, Finn? Okay, because we have 8x cubed over 8x squared. So it's just going to be x. That's exactly right. And then this is the one, Alex, I did want to touch one thing here. Yes, these all cancel out. We're not going to be left with 0. We're going to be left with 1, right? Because anything over itself is just 1. So our final answer is 2x squared plus 8x plus x, 2x squared plus x plus 1. So guys, sometimes when you do your division, it turns into this really nice looking polynomial, doesn't it? Sometimes you get these weird fractions at the end, but sometimes it works out perfectly. All right? And that's a wonderful, beautiful thing. Okay? For our last number 4 here, can someone help me out? Ava, what did we get for our first term?
3x.
Yes, ma'am. We got 3x squared. And then, Andrea, you want to help me out for my second term? Oh, sorry. Andrea Lopez and then Andrea R. How do I say your last name? Rincon. All right. Oh, I said that all right. I'm sorry. And so then you can do the last term. All right. So, Andrea, why don't you help me out? -4 because the x cubes just cancel out. Excellent job. And then Andrea R., what do we got? It stays the same. Nothing changes. You're absolutely right. It is already simplified, so we don't have to change that term. So it is 3x squared minus 4 plus 2 over x cubed. Do y'all feel pretty good about this? Okay? So you guys will have several problems like this just on your homework, okay? Now, let's go. I'm going to do something a little bit different. On this page, we were dividing by a monomial. Now we're going to get to divide by a binomial. All right? So we are going to divide by a binomial, and we are going to use a lovely little thing called long division. All right? So long division review. All right, guys? Let's do a little long division with just numbers. Are you guys cool with that? We're just going to do numbers. So let's check this out. So if I do 14,789 and I divide that by 12, no, don't just put it in your calculator. What we are going to do is we're actually going to just have a little refresher on long division here. So guys, remember, you do 12 divided by 14,789. So what is the first step you guys do in long division? when I have to explain this to my second grade daughter, guys, which she's not doing it yet, but she will. I think you guys learn it in elementary school, right? Third grade? I think third grade is when that magic number hits. Okay? So guys, remember, we want to see how many times 12 goes into this 14, right? So it goes into 14 one time. Are y'all cool with that?
8.114138.
Thank you. So that's actually not correct. So here we go. But here we go. Yay, I'm so glad this is being recorded. So here we go. So 1 times 12 is going to give us 12. So wait, Will. Yes, so Will, but what I want us to do is I want us to actually practice doing the long division because we're going to have to do it in just a second. Okay? So 1 times 12 is 12, right? Then what do we do next, guys? What's our next step with long division? You subtract. So we subtract the 12 and we get 2. Then you have to bring down your 7. Now we want to see how many times does 12 go into 27? 2. 2 times 12 is 24. Once again, you subtract. We get 3. You bring it down. So we have 38. How many times does 12 go into 38? 3 times. 3 times 12 is 36. Subtract it. You get 2. And that becomes 29. And then once again it goes in 2. 2 times 12 is 24. Once again we subtract. And we get 5. All right, this is kind of long. But guys, help me out here. What is this 5 right here? Do you guys remember what that's called? Because there's nothing else to bring down. This is your remainder. Do you guys remember doing this with a remainder? Okay. So your remainder is 5. So how we would write the answer is you would say plus 5 over 12. All right? So your correct answer is 1,232 plus 5/12. Okay? Now, yes, in our world today, most likely you would just use the calculator, right? And we would type in 4,789 divided by 12, and you get 1,232.416667, blah, 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 blah. Or you could also say 1,232 plus 5/12, and guess what, guys? It's going to be the same thing. How do you guys feel about that? Y'all feel pretty good? So, guys, 5 divided by 12 there, 5/12. All right? So we are going to use this same concept of long division to divide by a binomial. Divide polynomial by a polynomial. All right, guys? So now we are going to apply this long division with polynomials. So long division with polynomials. Okay? So we're going to now do long division here. So guys, we're going to use this same concept of multiply, subtract, multiply, subtract, multiply, subtract. Okay? And we are going to do this with our polynomials. So number 1 here is going to be x squared minus 7x plus 12 divided by x minus 3. Okay? So now we can't just do it over each term. We are going to divide, we are going to use long division when we have polynomial divided by a polynomial. So check this out. I'm going to rewrite this as x minus 3 on the outside. And we're going to have x squared minus 7x plus 12 on the inside. How do you guys feel about that? We are taking x squared minus 7x plus 12, and we're dividing it by x plus 3. Okay? So now we are going to do each term one at a time. So what you want to do, guys, is you want to think about how to cancel out that first term. So up here, in order for, what do I need to multiply by in order to get an x squared? I will need to multiply by an x. X times x is going to give me x squared. Are you guys comfortable with that? But x times negative 3 is going to give me negative 3x. So what I'm doing is I'm multiplying this guy here on the top by the x minus 3. Just like we did with our long division, we multiplied the 1 by the 12. Now I'm going to multiply the x by the x minus 3. And remember, when we did long division, once you multiply, then you subtract. So if I'm going to subtract my x squared, I also need to change the sign of my second term. So that becomes minus. That becomes a plus 3x. Okay? So we combine these together. What just happened to my x squareds? They canceled. Negative 7x plus 3x is negative 4x. Gentlemen, this is a brand new concept, okay? Now that we have this, we are going to bring down the 12. Do y'all feel good about that? It's just like long division with numbers, but instead we're using x's, we're using variables, okay? So now we want to think, what will I need to multiply this x by? How many times does x go into negative 4x? What do we need to multiply it by? Negative 4. So I'm going to multiply by negative 4. So negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. Do y'all feel good about that? Yes, ma'am? So, because remember, with long division, you subtract your term. So if I'm going to subtract everything in here, it's going to change the sign. So this would become, so right up here, that became a negative, and that one became a positive. So here, if we are subtracting this whole thing, this 4x becomes a positive, and this 12 becomes a negative.
My question was, how did we come up with 3? Are we choosing the 7x or the 3 on the other side?
So how'd you get the 3?
Yeah.
So I did x times x to get me x squared. Then I did x times negative 3 to get me negative 3x. Do you see that? No, you're good. And so then I changed the signs, and then I did negative 7 plus 3 gives me negative 4. So then I multiplied by negative 4. Negative 4 times x gave me negative 4x. Negative 4 times negative 3 gives me positive 12. But we're going to subtract all of these. So it changes that sign, it changes this sign. And look what happens. Negative 4x plus 4x, that cancels. Positive 12 minus 12 cancels. So what is my remainder for this problem right here, y'all? Yeah, my remainder is just 0. So this right here is the remainder. The remainder is 0. So my final answer right here, guys, is going to be x minus 4. We're going to do it a few more times to get some practice, okay? So for you guys to get in the groove here. All right? So let's look at number 2. Good questions, okay? So I'm going to do number 2. And the way I'm going to set up number 2 is I'm going to set it up as x squared minus 13x plus 42 over x minus 5. Are you good with that? So we're going to set this one up very similar, very, very similar to the way we set this guy up. Inside of our little division here, we're going to do our x squared minus 13x plus 42. And on the outside here, we're going to have x minus 5. Okay? So we are going to need to multiply x times something to get our x squared, right? So it's going to be x times x. Are y'all comfortable with that? So x times x is x squared. And then, Abby, we're going to go x times negative 5 to get that negative 5x. Do you feel good about that? Okay. Now, we are going to take this term here. So, we did x times x to get us x squared, and x times negative 5 to get us negative 5x.
Why do we do that?
Well, that's what we did with our long division up here, where you take this guy on top and you multiply it by your term here on the side. With regular long division, you multiply the top by the number on the side, right? So now we're just taking our variable on the top and multiplying it by our term on the side. Okay? So now we have to subtract them. So guys, you subtract your x squared, and that means that we are going to add the 5x, right? Because it was a minus 5x, but when you subtract it, it becomes a positive 5x. So then we bring this down. Our x squareds cancel, and we have negative 8x, and then we're going to bring down our plus 42, okay? Just like we bring down our numbers with our regular long division, okay? So then we want to think to ourselves, what do I need to multiply this x by in order to get negative 8x? Because we want that first term to cancel. So we just multiply it by negative 8. So negative 8 times x is negative 8x. Negative 8 times negative 5 is positive 40. So now we are going to subtract this whole term right here. So we change this sign, and we change that to be a negative. And we get negative, 42. So the 8x and negative 8x cancel. 42 minus 40 just gives us 2. So this guy right here, that is our remainder. Now we actually have a remainder, don't we? Okay? So our final answer is going to be x minus 8 plus 2 over x minus 5. That is going to be our final answer. You add the remainder divided by the divisor. So our final answer is x minus 8 over plus 2 over x minus 5. Okay? So I know this is a new concept, but you guys are doing great so far. And one thing that I want you guys to really pay attention to, guys, this is the mistake. This is where kids make their mistakes, okay? They make their mistakes by they just subtract the first, they just change the sign on the first term, they don't change the sign on the second term, okay? If you change the sign on the first term, you have to change the sign on the second term. So guys, that is where students typically make their mistakes, is they only change the sign on the first term. And by students, I also just mean people, because guys, when I was doing some of the notes on here, that was a mistake I made. And then I was like, what is, oh, right, okay, I got to subtract both of them. I got to change both the signs. So you got to make sure you change both your signs, okay? So now, let's take a look. I'm going to do another example for you guys, okay? So we're going to do one more example here. So let's take a look. Or actually, we're going to do several examples. But number 3, what I want y'all to do is we're going to do 6x squared plus 3x plus 4 over x minus 2. All right, guys? So I want you guys to do this one for me, okay? I want you guys to do this one for me, and I want to see how we do, okay? I'll set it up, but we want to make sure, I'm going to kind of set it up over here. Okay? All right, so we're going to take a look at this. We're going to see what we need to multiply first. All right, guys, I want you to try to multiply. For this first term, I saw some people just try to multiply by x, or some people just try to multiply by 6. But, guys, we need to multiply by 6x, because 6x times x gets you 6x squared. And then, we're going to do 6x times negative 2. What's that going to get me? Perfect. Okay? So that's negative 12x. Now we're going to subtract everything in this first line. So that means I have to change this sign, and I have to change that sign. So my 6x squareds cancel, and we are left with 15x. Then we're going to bring down the 4 plus 4. So now, what would I have to multiply by to get rid of my 15x? What are we going to multiply by? 15. So we're going to multiply by 15. So 15 times x is 15x. 15 times negative 2 is negative 30. And then I'm going to go here. I'm going to subtract everything, which means I have to change both the signs. Okay? Yes, sir?
How come the negative 30 somehow becomes a positive 30?
So when you subtract a negative, you change your sign. Because we're subtracting both. We're subtracting everything. So I'm subtracting 15, and I'm subtracting negative 30, so it becomes a positive. So this guy right here, good question, becomes 4 plus 30 is 34. And this right here is our remainder. So guys, if I asked you, what's the remainder for this problem? You would just tell me 34. That's it. You'd say remainder 34. All right? But if you wanted to write the whole answer out, we would write it as 6x plus 15 plus 34 over x minus 2. All right, guys? Do y'all feel good about that? And something that's important to note here is you always add the remainder. Okay? You always add the remainder. Even if it was negative 34 was my remainder, then I would say plus negative 34 over x minus 2. You always do a plus right here. Okay? This is always a plus. You always add your remainder. Okay? Yes, ma'am.
Wouldn't you simplify the 34 over x minus 2 because it's negative 4?
But you can't, because you can't, this is one term. So this is as simplified as it gets. Or this is one factor. So you couldn't do like 34 over x and 34 over negative 2. It doesn't simplify. So if you could simplify, you would, but this does not simplify. Okay? Y'all feel good about that? So it's 6x plus 15 plus 34 over x minus 2. All right. So now I'm going to throw another little winch in the system here. Okay? So our next one here, because we still got some good time. So guys, let's check this out. So what I'm going to do is, guys, if we have 2x squared plus 14 over x plus 4, we have a problem. Because in this top guy up here, we have an x squared, but we don't have an x. So guys, when you have this type of problem, what you want to do is you will always need to add or fill in a 0 for each missing term. So, you will need to fill in a 0 for each missing term. Okay, I'm going to add term over here. Now, basically, guys, what it does is that's going to be like a placeholder. Okay? Because otherwise, it gets really screwed up when you try to divide. Your like terms don't line up. Okay? If you don't do this. So what this means is for this particular problem, I'm going to have my x plus 4 on the outside, but I'm going to divide by 2x squared, and then I'm going to just add in a 0x right here, and then plus 14. Okay? Because we have an x squared term, but we don't have an x term, so it's kind of like a 0x. You could also just put 0, but this reminds me that it's for my x term. And what this does is this allows us to, I'm going to say each missing term right here. So guys, what this does is this allows our like terms to line up properly. All right, y'all? Because otherwise your like terms are going to be all mismatched and it's going to get really confusing. So now let's solve this problem here. So what will I need to multiply by in order to cancel out this 2x squared? What am I going to multiply by here? Just 2x. Exactly. 2x times x gets me 2x squared. 2x times 4 gets me plus 8x. Are you guys good with that? Okay? And then we got 2x squared. Now we are going to subtract everything in here. So this one becomes negative 2, and this becomes a negative 8. I'm going to change both those signs. Does that make sense? That right there is one of the biggest mistakes people make. They only subtract this one. They forget to change that sign. So then we cancel this lovely guy out, and we have 0x minus 8x is negative 8x. And then we bring down our 14. So what it does, guys, is it just fills in that place so that our like terms match up. Does that make sense, guys? Okay? So then we go here, and now we got negative 8x and x. So I want to multiply by negative 8. So negative 8 times x is negative 8x. Negative 8 times 4 is negative 32. I'm going to subtract both of these, which means I change both their signs to positive. Because when you subtract a negative, it becomes positive. And that right there, it cancels out to 0. And then what is that going to be? What? 46? Is that right? So this 46 is my new remainder. Okay? So then the final answer would be 2x minus 8 plus 46 over x plus 4. Okay? How do y'all feel about this so far? Pretty good? All right, we're going to do one more, and then I want to let you guys do your homework. Okay? We're going to do one more together. Alrighty. So, last problem. We're going to have one where we're going to fill in a missing term here as well. We're going to do one more. So, number 5, I'm going to write as 3x squared minus 2x plus 3 over x squared plus 1. So now, the top one doesn't have any missing terms, but my divisor does, right? So when we rewrite this, how we're going to rewrite it with the missing term is I'm going to write x squared plus 0x plus 1 on the outside. And then I'm going to do 3x squared minus 2x plus 3 on the inside. So I'm going to add that missing term in right here. Remember to fill in your missing term. Okay? So now this one's going to be a little bit different. X squared times what gives me 3x squared? Just 3. That's it. So 3 times x squared is 3x squared. 3 times 0x is still just 0x. Are you guys cool with that? We're just kind of using it as a placeholder. And then 3 times 1 is just 3. So this one's interesting. Now we're kind of dividing by a trinomial here. Okay? With that 0x. So now we're going to subtract each term, which means every term is going to become negative here. And what's really interesting is my 3x squared cancels out. Negative 2 minus 0 is still just negative 2x. And look at that. My 3 minus 3, that also cancels out. Do I have anything more to bring down? No. So this is what I'm left with. This is the remainder. Okay? So that negative 2x is the remainder. So I would just write my answer as 3. Remember, you always add your remainder plus negative 2x over x squared plus 1. Okay? So you always, always, always add your remainder. Okay? So I would say the biggest things that you will need to remember for this is to always add your remainder, and remember when you subtract it to change all the signs. Okay? So if you need to put those little reminders, always add the remainder. And that was, sorry, yes. So you always add the remainder, and when you subtract, to change each sign. Okay? That's super, super important. Okay? So when you subtract, remember to change each sign. All right, y'all? So I know it was a little bit longer today.